living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. The world where we glide, from the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. The heart of the tech beehive. Liquid galaxy, we see an old technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Tech beehive. In the heart of the tech beehive. In the heart of the tech beehive. Screens, living in the grand spatial dream. Visualize just what we mean. Innovation shaping our fate. Together we celebrate. From data to display, community lights the way. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. The streetways are wide, to the world where we glide. From the peaks to the seas, exploring with ease. Mapping the future's bright, our bond ignites the night. Collaborate, innovate, together we elevate. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see an old technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Liquid galaxy, we see it all. Technological marvel standing tall. Liquid galaxy, together we thrive. In the heart of the tech beehive. Tech beehive. In the heart of the tech beehive. In the heart of the tech beehive. heart of the galaxy where the stars align. We gather as a community with a vision so divine. Panoramic views, a world we can explore. With Liquid Galaxy, we open up the door. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide. Gaia spatial wonders unfolding at our feet. A journey through the cosmos, a visual retreat. From mountains to the oceans, we see it all so clear. With every map and image, the universe draws near. Echoes of the galaxy in every beat we play. Innovation shining bright, lighting up our way. Together we create, with passion and with pride. In the Liquid Galaxy, our dreams and worlds collide.
Hey everyone, my name is Agnindra Sinha and I am from India pursuing my BTech from IIT ISM Dhanbad. Today I will show you the working of the AI feature in my proposal, which is Urban Viz. So let's start. So let's start with a small introduction. So like my AI tool will be used for traffic congestion, real-time traffic monitoring challenges like let's say if there is too much traffic in some area, then for better planning of that traffic, we will be using this AI feature. And AI feature will be using live CCTV streams, which we will get from a link which I have shown later. And this AI feature does not require any kind of backend or Python dependencies from the app. Yes, we do need Python, but this will be done in the pre-processing of the model. Like we will use the YOLO v5 model for this object tracking, and that YOLO v5 model will be converted to an Onyx model, which which then will be converted to TF Lite model. So this entire process of converting the YOLO v5 to Onyx to TF Lite will be done using Python. Only that is the portion which needs to be done in Python, which the user does not need to do, but the developer, that is me, will only do it in Python. Other than that, no Python dependencies are there for this. So let's move forward. So here is the small workflow. Like we will input a live CCTV stream, and we will use the Flutter MJPEG um, package for viewing that CCTV stream. We will use the YOLO v5 model converted to TF Lite, and we will also use a pure Dart based IOU tracker, which is intersection over union tracker, for like tracking any specific vehicle. More on this later. The next, so this is the stream handling portion. As I said, this MJPG package will accept yes, the MJPEG package will accept a stream variable where we will pass this live stream, which is like this is a live stream of CCTV footage in Romania, and we will set is live equals to true. The next, this is the YOLO v5 model conversion to TF Lite. So like first two commands we will pass it in our command prompt. Like first we will clone the YOLO v5 model from Ultralytics, then we will use the YOLO v5 N model, that is the YOLO v5 nano model for this project. And then we will install the requirements, and then using Python we will export this YOLO v5 n.pt, which is a PyTorch file, and convert it into Onyx file as mentioned. Then for converting this Onyx to TF Lite, we will run this Python script which will convert this Onyx to TF Lite, and this is the only portion that is needed to be done in Python, and that too only once. So let's move forward. For loading this YOLO v5 model in Flutter, we will use these two lines. Like first, we will obviously install the TF-Lite Flutter package and then import it. And then with these two lines, we can use the YOLO v5 n.tflite file that we created here. like from this Onyx model, uh, this YOLO v5 tflight file will be used here as an interpreter, which is a class from the tflight flutter. So here is the inference class of the dar of the YOLO detector. So this YOLO detector inference class will be used for like running the model on the given CCTV footage. So we are firstly initializing the interpreter, and then we are loading the model here. Then this pre-process function is used to undergo some pre-processing that we need to do in the CCTV footage before passing it to the YOLO v5 model. And then by using this run inference, the CCTV footage will be fed into the YOLO v5 model and result will be gained from there. Then after detecting all the objects, we will use this non-maximum suppression feature, which is used for filtering out any low confidence and overlapping boxes. Like if there like there's let's say there is a car which is detected, but its confidence is very low. Like maybe like that car is actually not a car, but the model detects a car but with very less confidence, so we will not accept that. So that's why this NMS non-maximum suppression model is used. And also if there is any kind of overlapping, then also we will not consider that object. Like this will increase our accuracy and performance. So let's start with the IOU. So first I have defined a like a class for the tracked object, which is needed for for giving the ID, then the B box, like the boundary box, then for calculating the centroid, and also we will take a parameter called last seen frame. And then the IOU code will be given here, which I am explaining right now. So here is the IOU logic. So the void update, which is this function I have explained it better in the next slide. So first it will let's say it will take one frame from the video, and then this current frame plus plus is used to keep track of how many frames have been yes have been processed. So this first, like after taking one frame, the value of current frame will increase by one. Then we have created a list of tracked object, which is this class. So we will be running a for loop here for every new frame counter which is encountered. And so then we will calculate the centroid using this new box dot center. And we have initialized a variable called best IOU with 0 point 0 and a best match variable. Then we will check for the tracked objects which are present here. And then we will like calculate the IOU. So let's explain the calculate IOU here. So the function for I mean the formula for IOU is basically the mathematical formula of A intersection B by this, like intersection area and union area, whose formula is this. So like this calculate IOU function is basically the code version of this mathematical formula. So that's what I have written here. So the IOU will be returned, and then like we will always store the best IOU from the calculated values, and like stored in the best IOU, and the corresponding match for that IOU will be stored in the best match variable. Then I have also applied a kind of threshold value here, like if the best IOU is greater than 0.3, then only the detection is considered a match with the existing object. Otherwise, like if the detection is like if it the IO best IO is less than 0.3, that means that a new vehicle has been detected. And thus we perform this function, which like adds a new vehicle to the updated tracks for list. And then the tracked objects will become gets updated with the updated tracks list, which was here. So let's start with some optimizations. So what we can do is, instead of performing the object detection for every frame, we can do it for every third frame instead. But but the tracking portion, which is the IOU tracking, that can be done for every frame, because the IOU tracking is comparatively low weight than detection and then the object detection, which uses TF light model, and that will be very efficient for us, so that the high weight TF light model will not be used for tracking in every frame. Lastly, the performance that we have seen here is like the frames per second for an average Android mobile will be like approximately 8 to 12 FPS, and like this yellow model will obviously detect any kinds of vehicle, like say any kind of two wheelers or four wheelers, including like trucks or buses or cars. So yeah, this was my presentation for the Build with AI video, and thank you.
Hey everyone, my name is Shivam, and I'm currently a third year BTech student studying computer science. And I'm really excited to share my project for Liquid Galaxy Kiss AI contest. Simply Kiss stands for Keep It Simple and Stupid, and that was definitely a goal there to create a straightforward, easy to understand application that's connect to a simple AI response, which is used to visualizing to the Liquid Galaxy. So the idea is to show how we can use simple web applications just like HTML, CSS, and vanilla JavaScript to interact with an AI models. So in this project, I've used in Google Gemini, and and the response which we get, we will use to show on the Liquid Galaxy like coordinates, text, and etc. So let's head to the project. So let's there's my file application, project application. Open with VS Code, and there's the file structure. As you can see, there is JavaScript file folder and it consists API.js, main.js, utils.js, and HTML and CSS files. So let's go to the live. We will live. All right there. App is running in my browser. As you can see, it's got a pretty simple layout, and at the top having a navigation bar which consists chat, setting, and LG controls. So before chat, let's explore settings. So in setting, it consists IP address, LG port, username, password, and all the necessary things. And there is Gemini API key. So this is important for one of for our AI. You will get that API key from the Google Studio. Let me show you how you can get that one. So let's head to the Gemini. Yeah. So there, Gemini API. Get a Gemini API key. Create API key. So select the project. Where my first project, create API key in existing project. So it's generating. So there is your API key. Never show your API keys is not a good thing. After the video, I will remove that key. So this is the way you can get your own API key. For that, let's head to the project. So let's head to the project. Before that, let's connect. First, let me open my bits. Forget it. Start, start, start. So it's starting. Let's discover something else. LG controls. I have considered four LG buttons. It's relaunch, shutdown, reboot LG, clean bubbles. So it's basically a four one. Let's go to the chat setting. It's a simple UI as you can see. You can ask your question there. Let's see. Uh, Let me even first. I forget. Then let me first run the server. Galaxy and GSoC. Let's open the PS code. There. PM. Then the so our server is now running. Localhost 3000. So rigs are now working. Let's stop locating first. Uh, Apply. Now it's working fine with God. So at the chat section. So let us question something. Alright. Here is a little one. Uh yeah, the response which are so this is the first function successful chat. So let's visualize something. Let's we go to the Hong Kong. On the Alimis. So it's given the coordinates. Let's visualize sending visualization and do compute. Ah, it's working. So let me just launch this again. Let's go for the India. What is visualize? Yeah, it's working fine. It's flying to the location India as it's working. It has, yeah, that's good. Bubbles are not showing. Let me refresh the speed. Yeah, the bubbles are working fine as we want. It's showing all the response text which we get. And here, as you can see, it's the same as the generative response. So let's get to some more places. It might be Hawaii. Hawaii. Why will you coordinates? Companies. Hawaii coordinates. So it's working as we want. The KML, the bubble part needs to refresh. Then it will show. I think it needs to clear first. Then it will show. Let's go to the easy controls. Team bubbles. Let me visualize again. Visualize. So let's check it out. It's what's on. Sometimes bubbles show, sometimes not. It's a refreshing issue. It might work for you. Let's try again. Might work. So close that. It's not showing. It might be a refresh problem. It will. Sure, sometimes it. So head to the next part. Let me show you some interesting things. If I if I ask about anything, let me ask about that one. About touch. Health. Good touch. So as you can see, it's given the details about the Taj Mahal, but not showing button visualize to LG because it doesn't have any coordinates. So before visualize to LG, we need a coordinate. So if I ask, is it Taj Mahal coordinates? Coordinates? As you can see, it appears visualized. So it's necessary to have a response having a coordinates, then it will show to the liquid galaxy. So this is the end. Mm, so that's the end. This application is Algik's application, a simple demonstration of connecting Gemini AI to Liquid Galaxy using basic HTML, CSS, and JavaScript. It's made the KISS contest goal of a small open source application, showing AI use case to the Liquid Galaxy. Uh, and I hope you find it interesting. So, bye now.
Dear Liquid Galaxy team, I'm Mahib Singh from India. I currently study engineering as a sophomore at the Indian Institute of Technology, Roorkee. My project's name is WonderGlobe. To give you a short summary about the project, the goal of the project is to utilize the immersiveness provided by the Liquid Galaxy when exploring satellite view through Google Earth or Google Street View, as proven by the Perusaru project, and make the experience even more enjoyable by gamifying it. I plan to create a location guessing game. The player will start at a random location shown in the street view via a web app which will be synced on the master and the slave rigs. The satellite view of the same location will be shown on Google Earth as well using a KML. To make sure that the user cannot cheat by simply zooming out in the satellite view, we will use a ground overlay which is opaque otherwise except a small transparent window at an appropriate location to ensure that the user can see the satellite view of the location to be guessed. We will also turn off the labels. The locations will be selected randomly from a set of 100,000 locations, pre-generated via a map-making tool called Map Generator, which on selecting a country can generate the specified number of random street view locations. It allows for the exclusion of unofficial or user-submitted street view coverage, allowing us to utilize only the best quality panoramas. At the end of the game, the correct location and its distance from the guest location will be visualized on the Liquid Galaxy. Using polygons of different colors, first the whole country will be highlighted, then a small region around the correct location. The exact correct location as well as place guess will be shown with the help of place marks along with a polyline to represent the distance between the two, followed by a tour between them. Information such as point scored, hints, time left will be shown by bubbles on the liquid galaxy as can be seen in this image here. The Flutter app will handle the storage and selection of locations. Apart from that, it will act as a controller for the location for the Liquid Galaxy through a gamepad and a trackpad and allow for switching between satellite view and street view. The Flutter app will also show the player's game statistics such as average time per guess, high score, etc. I plan to create 6 game modes, namely the classic, campaign, educational, speedrun, multiplayer, and fog mode, which have been described in detail in my proposal. Now coming on to AI and build with AI. The Gemini API will be utilized for two main applications. The first being hinting and the second being the educational game mode. On the settings difficulty page, the user may toggle hinting on or off. On doing so, the user will be shown hints to help them guess the location at regular intervals of 20 seconds, with more distinctive hints being provided as time goes on. That is to say, as time goes on, the hints will become more distinctive to the location to be guessed, making it easier to guess. The education game mode intends to provide a fun and engaging way of learning. It relies on Gemini to generate coordinates for locations based on the user's request. For example, the user may prompt for the capital of United States, US states. This can help teach what historically or culturally important places look like and where they are located in a gamified fashion. The Map Tiles API is used to check whether Street View panoramas exist within a certain radius of the coordinates provided by Gemini. As you can see on the slide, the radius for which the panoramas are to be checked can be specified in the request for the Pano IDs API. So we can check whether an appropriate panorama exists within a certain radius, say 1 kilometer, of the coordinates provided by the Gemini API. Now, after the guess has been made, along with visualization, educational information about the location generated by Gemini will also be shown as a bubble on the Liquid Galaxy. It will also provide for a surprise me option, which will ask Gemini to find a random set of coordinates in countries with Street View and teach about them to the user, as can be seen here on the button, through this button. I have created a small demo app to demonstrate both these applications of the Gemini API. The demo app. In the demo app, the responses are shown in the Flutter application. However, in the final project, the hints and education information will be shown on the Liquid Galaxy through bubbles. As can be seen here, in the bubble, the educational information about the coordinates generated by the Liquid Galaxy are shown in the bubble on the side. This demonstrates the educational game mode. Here in this image, we can see the hints in the bubble on the rightmost slave of the Liquid Galaxy rig. Now moving on to the demo. First I'll demonstrate the hinting part of the application. Here I can enter multiple coordinates. For example, say and when I hit generate hints, it will generate a set of 6 hints each for both the coordinates. These coordinates describe the locations while still making these hints describe the locations while still ensuring that the exact name of the location or any surrounding countries or the continent is not said directly. This ensures that the hints guide the user but do not tell the answer completely. Also, the hints get more descriptive as the number goes on. That is to say that more distinctive hints that which pertain more to the location to be guessed are provided as time moves forward. That is, the hint 6 will be more descriptive than hint 1. Now moving on to the educational game mode demonstration. Here we can enter any topic, say the capitals of the US states. And when I click on generate, Gemini API will generate not only the coordinates for the locations, but also short descriptions for each of the location, short educational descriptions for each of the location. I'm sorry for the misclicks. Now moving on to the surprise me button. When I click the surprise me button, it will Gemini API will generate a topic to uh, teach about through the educational game mode by itself. Here, it will not only generate the coordinates for the location, but also short descriptions for each of the location, short educational descriptions for each of the location. These are the services that I have written to provide the prompts for each of these each of these applications of the Gemini API. Here in the hinting prompt, it can be seen that I have described carefully how the hints should look like, including what they should or should not contain, and how they should get more descriptive as the index of the hint increases. I have also clearly defined the format for the output to ensure that unexpected outputs do not cause problems. For the educational game mode prompt, I have also provided it with all of the with all of the countries which have considerable Street View coverage. This ensures that it only generates coordinates which do have Street View coverage available. I have done the same for the surprise uh, me service. These countries were scraped. Now moving back to the presentation, coming to pricing, I intend to utilize the Gemini 2.0 Flash model because it's sufficiently intelligent as well as fast for the application. The free tier of this model allows for 1500 requests per day. Since hints can be generated for all rounds of a classic game at once, the game mode which would require the highest number of requests is speedrun mode. Now, assuming that the player is able to guess 5 locations per minute throughout the gameplay of 15 minutes, which is extremely high, the user would be unable to exhaust the free tier's daily request limit even if they played throughout the day. Similarly, for the education game mode, the player would be unable to exhaust the API's daily free limit through normal gameplay. Since locations for one game, that is 5 rounds, can be easily fetched through a single request. The map tiles API, which will be used once per game to verify if the generated coordinates have proximate street views, gives 100,000 free monthly requests, that is 100,000 free monthly games. So, for all applications of the Gemini API, the user will be unable to exhaust the free limit, even if they played the game throughout the day. Now, coming to what makes my proposal special. Since the idea was picked from the list provided by the organization, what makes my proposal special is that I plan to make a set of 6 diverse game modes which can be engaging for all sets of audiences. With educational game mode, I seek to create an app which can create an educational experience as well, allowing people to experience as well as learn about culturally, historically, or geographically important places in a completely new way. Furthermore, the gamified experience would create the could make it so that the learning experience is even more engaging. Moreover, since each game mode will allow for 3 difficulty modes, namely move, and no move, no pan, no zoom, as well as an option for hinting, and the user will be able to choose his preferred way to control the Liquid Galaxy as well, I feel that my project will be able to provide an engaging and a highly customizable experience to people. Now coming to why should my proposal be selected. The quality as well as coverage of Street View has been greatly enhanced since the Perusaru project was made around 10 years ago. Hence, I feel that Liquid Galaxy or uh, hence I feel that the Liquid Galaxy organization should utilize Street View for another project, especially given the immersiveness that it can provide to the Street View experience. I feel gamifying it, and by providing game statistics through the Flutter app, which players would seek to improve, could further enhance the experience, making it more engaging and more appealing to a wider set of audience. Thank you so much.